Hi guys, this is probably going to be one of two videos to help you review for your Chapter 6 test. So I wanted to start with some things that we haven't seen in a while. We opened the chapter kind of talking about random variables, which just meant that you had numerical outcomes or numerical values for every outcome. And then of course the probabilities aligning with each. Then we talked a lot about Pete and Aaron's Jeep tours, and we learned how to transform and combine random variables with that example. So when you are transforming, just remember that you can change everything to the mean, but with standard deviation, you're never adding and subtracting. I know you guys know that, it's just a lot of you forget to do it on the test. You end up adding something to a standard deviation, and then you get that part wrong. So just a little refresher there. So with combining random variables, that's when we added Pete to Aaron's, or we subtracted and looked at the difference of Pete and Aaron's. So when you add them, it's easy because you just add the means together, and then you, in a way, add the standard deviations. But if you remember, mathematically that was incorrect just to add those two. So we had to square them to get the variance, then add the variances together, then finally take the square root in order to get that standard deviation. If you notice with the difference, that part's easy. Just subtract the two means. But look, I didn't change anything about doing the process for the standard deviation. What we talked about was that even when we subtract random variables, the spread is growing because you're subtracting every possible outcome in one from the other. So there's a lot more possible outcomes when we look at the difference. So the spread grows as well for that. So that would have helped you with this question on your review guide. It's kind of a tricky question. I threw it in there just to see how well you guys could do it. Essentially what you had to recognize was that every day represented one random variable. So just one day he would use approximately 0.21 ounces. So the next time he brushes his teeth, he's going to use approximately 0.21 ounces, and the next time he's also going to use approximately 0.21 ounces. There's a standard deviation of 0.07. You know you don't squeeze the exact amount of toothpaste out every time. So that's when we were looking at this 3 times. So because we're adding together day 1, day 2, day 3, this would be a sum problem. So we're looking at the sum of 3 random variables, day 1, day 2, day 3. So this problem goes directly back to adding together 2 random variables. So I'm doing the same thing with 2 as I would with 3, just adding them all up. Finding that over the 3 days he should use about 0.63 ounces. But with the standard deviation, remember we have to get the variance, so I squared it for day 2, squared it for day 3. Then I could add those all up, so just be very careful with doing that in your calculator. Finally, take the square root, and he's going to use, kind of on average, a difference of 0.121 ounces. So in 3 days, he uses about 0.63 with a standard deviation of 0.121. So what's the probability he'll use it all? This is where it got a little tricky. You had to go to the back to the top of the problem. There's 0.85 ounces in the tube of toothpaste. It's a little guy. So he's going to use about 0.63. So what are the chances that he just squeezes out too much and ends up using the entire tube of toothpaste? We'd have to use the normal curve. Here they let us know it was a normal distribution. That's really the only way we can solve this one. So if he's going to run out, it means he's going to use more than 0.85, or at least 0.85. So I made my lower bound 0.85. The upper bound is infinity, because we're just assuming it's everything greater than that value. Here's my mean, here's my standard deviation. You end up with a 3.5% chance. Some of the other ones that would remind me of stuff that we did at the beginning of the year. Number 7. This looks like a typical probability distribution, but they've thrown variables in here. So what you had to remember is that the sum of the probabilities must equal 1. So they're trying to get you to solve an algebra problem is all. So we have 3c plus 2c plus 0.4 plus 0.1, and then you can see I just solved it for c. Same thing with the number 8. I'm setting up my own probability distribution, and this was the very beginning of the unit. We had to do the expected value, and in this case the expected value was 11,450. So I just took 20,000 times 0.6 plus 5,000 times 0.25 plus 0.25 times 12,000 times 0.15. Okay, one of the other things I wrote down for you guys is what you're going to have to know for binomial distributions and geometric distributions. Geometric distributions, you don't get anything on the formula sheet. So you should know this formula. This is the probability of failure to k minus 1. That means that you're failing right up until you finally succeed. So if they want you to succeed on the 7th trial, then this would be the number 6. Very intuitive, or you can definitely just use geometric PDF or CDF. The only reason I think you should know these two is sometimes they try and sneak them into multiple choice questions. So luckily for the binomial distributions, the formula sheet provides this. You just kind of have to remember what n choose k means. So that's what we used in our calculator. If you go to math probability and then number 3, you see NCR. That's where that came from. Probability of success, and then the number of successes that we were interested in, probability of failure, and this would be the number of failures. So the formula sheet also gives you this formula. That's your expected number of successes, that's your mean. It also gives you your standard deviation. Formula sheet does not give you this for geometric, so you must know this on your own. So for example, if we wanted to say what's the probability we don't land on a 4 on a die, or when can we expect to first land on a 4? There's 6 choices, so that would be 1 divided by 1/6, which gets us the 6th turn. We talked about that a lot in class. So using that idea, just be very careful. I think they tried to throw you off with the 10-sided die and using 10 choose 4 in A and B. But we're rolling it 12 times and we want to get 4 of the successes. So really it's D, 12 choose 4. The 1/10 is where this comes in. So there's a 1/10 of a chance of getting that 8 4 times. And so then we're failing to get the 8. This is failing to get the 8. It's getting any other number besides 8 times. Number 10 reminds me a lot of what I showed you on the slide, that we have to take the variance of each and add those together. This question specifically asked you for the variance, which is why you don't see the square root sign. One thing we did talk about is that x and y have to be independent in order to add the standard deviations together. So I don't think you'll have to worry about that on a free response question, but they will throw those in to the multiple choice questions, obviously. All right, I'm going to stop this video here and hopefully kind of pick up back again with the next one so it's not too long.